In this video, we are going to see about joining strategies in PySpark using some real-time examples. There are a lot of joining strategies are available, but I'm going to explain around 3 joining strategies quickly. Things which I'm going to explain in this video are very important when you are working in real-time projects, especially. So these joining strategies and its mechanisms should need to be understood when you are doing it with big data. So the first one is the broadcast join. So see the code here. The broadcast join is one of the common joining pattern apart from its Spark's default joining behavior. In order to use this join, you should write a dedicated syntax to implement the broadcast join here. Why we are using it and what is the benefit of it? Let's see those things. For example, we have two data frame, df1 having the customer transactions log and its size is 100 GB. And we have df2 and we have around 50 MB. It is having a customer metadata. So when you have this type of scenario, like one data frame is very big and another one is small, you can use the broadcast join in order to optimize the full potential of it. So in the backend, how it will work is, when you're not using the broadcast join, your df1 and df2 both will shuffle across the cluster. So significantly, it will reduce the speed of processing and provides more latency when you're processing the big data. But if you have the broadcast implemented, you have to put your smallest data frame in the broadcast. So it will be available in all the executors. After that, when you're doing the join with df1, since the df1 is partitioned in the backend, each partition data of df1 will join with df2. So the shuffling won't happen in this type of scenario. So this is the approach of broadcast join. When you have this ideal case of above, you can consider the broadcast joining. Next one is a shuffle merge join. This is default join which Spark will taken in hand when you didn't mention any broadcast in your code. If you see the code, I set the configuration, it will disable the broadcast join feature internally so that we are forcing ourselves here to use the shuffle merge join strategies. The idea behind the joining strategy is it will useful when you have two big data frames to join, but in order to use this fully resourceful, you should partition the data properly. There shouldn't be any skewness in between the partitions of your data. Then only you can attain good results when you do this join. Okay. And if you want to know about how to clear out the skewness in your partition data, you can see this video. So in this video, I explained everything about how to handle the skewness and how to neutralize the skewness and everything. Okay. So you can go and check this video for better clarity. The last one we have here is Cartesian join or cross join. I have never used this join highly. Basically, I learned this for prepping up for my interviews. So how this join will work, when you have df1 and df2, it will take the rows of df1 and df2 and get multiplied itself. This join here is very expensive because it will simply return the product of your two data frame rows. For example, if you have 1 million records on df1 and in the df2 you have 10k records, and if you are doing the Cartesian join, you will get 10 billion rows. Most of the time, if you perform this joining strategy, you will end up getting out of memory error and it may lead to crash your Spark job. You should be very careful enough to use this. Mainly this is used to check the permutations, and if you have any matrix level calculations in your code, it should be feasible with those scenarios. The reason behind making this video is very simple. This is one of the important optimization techniques on joins in PySpark for handling the big data sets. These questions are often asked in interviews. From my personal point of view, this is very important, so that's why I make this video. So that's all about this video. I hope you understand the joining strategies, and if you have any comments about this video, just comment it down. And that's all about this video. See you guys in the next one.